In section 3.1, we're going to be learning the terminology for probability. An experiment is something that you do that is under controlled conditions. So nothing is predetermined. Everything that happens just happened by chance. So if you were rolling a fair die that was not weighted and it happened to land on 5, well, it just happened to land on 5 by chance. It wasn't weighted to land on 5. An outcome is some kind of result from your experiment. So if we were rolling a die, the outcomes could be, say it was a 6-sided die, it could be 1, 2, 3, 4, 5, or 6. If I was flipping a coin, it could be heads or tails. Both of those would be outcomes. Now, something called a sample space, that is a set of all the possible outcomes grouped together. And so what we use for this is a uppercase letter S. So that's going to denote that this is talking about the sample space for your experiment. Kind of like this right here, S is equal to heads and tails. That's every single possible outcomes that you could have if you were flipping a fair coin. Okay, now an event is any combination of the outcomes. So we could say, what's the probability of rolling a 2 and then a 5, or rolling a 3 or a 4? So that would be a combination of the outcomes, or the combination of what could happen based on the experiment that we're using. Now, to represent your events, you can use uppercase letters like A and B, C, D, depends on how many events that you're looking at. Now, if you're trying to find the probability of that event, well, this is how you would write it. Probability of event A. Okay, so P denotes probability. A, B, C, D, E, F, you keep on going, denotes your specific event that you're looking for. So when you put them together, this really says the probability of event A occurring. Now, two things about probabilities. It's always between 0 and 1. If the probability is equal to 0, that means that that event is impossible to happen. It cannot happen. There's a 0% chance of it happening. And if probability is equal to 1, then it's absolutely certain that it's going to happen. 100% it's going to happen. Okay, now we're looking at the probability of any outcome is the long-term relative frequency of that outcome. So we're not looking at it just 10 times and seeing what is the probability. Say you were flipping a coin and you flipped the coin 10 times. Now it wouldn't always happen to be exactly 10 heads or 5 heads, exactly 5 tails. It could be a little lopsided to one or the other. But if you keep doing that 20 times, 2,000 times, 20,000 times, then what's your probabilities between heads and tails? They're going to approach a 50-50 mark. So that's what we're saying. We're looking at the long-term relative frequency for that outcome. Now, something is called equal likely if all the outcomes of an experiment occur with equal probability, or really just the same probability. So if we had a fair die, so we could roll a 1, a 2, a 3, a 4, a 5, a 6. The probability of getting a 1 would be 1 out of 6. A 2 would be 1 out of 6. All of these would be 1 out of 6. Okay, so since each one of these have this exact same probability, then they are equal likely. Now, an unfair or biased event, that's basically the opposite of equal likely. So these are not equal likely. Some type of outcome is favored over another one, kind of like a weighted coin or a weighted die. Okay, so this is how we're going to find the probability of equal likely events. You're going to count the number of outcomes for event A divided by all the outcomes total in your sample space. So like this one, we're going to flip a coin 3 times. And then here's our events over here. Now before I try to find my event, I need to find my sample space, which is all the possible outcomes. So I'm flipping this coin 3 times. So I need to figure out how many items will be in my sample space. So if I've got 3 coins, now I'm flipping a coin, so I only have 2 outcomes, heads or tail, for the first coin flip. For the second coin flip, heads or tails. For the third coin flip, heads or tails. Now to get all the possible outcomes, all I got to do is multiply these together. So I should have 8 different outcomes. Now here's a list of every single outcome. Could be all heads, could be heads, heads, tail. And here the order is going to matter, or it could be a head and then a tail and then a head, or a tail first and then a head, then a head. And then you do the same thing, tail, 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 head, tail, head, tail, head, tail, tail. So those are all the possible outcomes. So put all of them together. This is our sample space S. So each one of these is an outcome. So I have 8 outcomes here. Okay, so I'm looking for event, we'll say this is event A. We'll find the probability of event A. 1 head and 2 tails. Okay, so I'm looking for 1 head, 2 tails. So I have one right here. There's 1 head, 2 tails. Here and here. So count the number of ways event A happens. Well, 1, 2, 3. Out of your sample space, which we found to be 8. And there's a probability of event A happening. Okay, 1 tail, 2 heads. 1 tail right here, here, and here. So same thing. Probability of B would be 3 over 8. Okay, 3 heads. I just have one of those. So probability, we'll say this is C. Of C would be 1 over 8. And then 3 tails. We just got one of those. We'll call that D. Probability of D would be 1 over 8. Notice that all of my outcomes are highlighted. Now, if I add up all of these together, so I'm going to 3 plus 3, 6, plus 1, 7, plus 1, 8. So I get 8 over 8, which is 1. So if I look at the probability of from A all the way to D, the probability of event A through D happening would be 1 because we've highlighted the whole thing here. Okay. Now something called an OR event. So what you're going to do is you're going to put together everything, except you're not going to list the repeats twice. You're just going to list them once. So this is putting everything together, no repeats. So if I've got event A and event B, and I'm trying to look for A or B, well, I'm going to take the 1, 2, 3, 4, 5, put it here. And then, okay, I've already got a 4 listed. I've already got a 5 listed. I'm not going to list them again. Then I'll take the 6, 7, and 8. So then here you've combined both A and B without the repeats. And event, that's just seeing where the two events have something in common. So if you look at, this is A right here, and then this is B right here. So you see, okay, between this one and this one, what numbers do they have in common? Well, that's just 4 and 5. So A and B would just be 4 and 5. So an OR event is putting everything together, no repeats. An AND event is finding what they have in common. Complementary events, so you can list it 2 ways. It can be A prime or it could be A bar. Both of those say that this is the complement of A. Okay, so the complement of event A, or A prime or A bar, consists of all the outcomes in which A does not occur. Okay, so if we say that event A is rolling a 2 or rolling an even number. Okay, so on a 6-sided die. Then A prime would be everything that A is not. So that would be rolling an odd number. Okay, if we look at the probability of rolling an even number on a 6-sided die, that would be a 2, a 4, and a 6. So that'd be 3 numbers out of 6, or half of them. And if we looked at rolling an odd number, that would be a 1, a 3, and a 5. So it'd be 3 out of 6 again, or half. Now if I added these two, so probability of A, we said was a half, plus probability of A bar would be a half. Well, 1 equals 1. Because what you've basically done here is you've gathered up all the outcomes and found the probability of them, and then you're adding them all up together. kind of like we did here in this example here. We gathered up all the possible outcomes and then we added them all up. If we have all the outcomes and we add them up, it's going to equal 1 for your probability. Okay, now conditional probability is just how it sounds. There's a condition to the probability. So the conditional probability of A given B, and you can write this given with this line right here. That's what it means. A given B is written probability of A given B. So what this says is the probability that event A will occur given that B has already occurred. So this second one here, this has to happen first, and then you can go back and look at the probability of A. Now, the formula for it is the probability of A and B divided by the probability of B. How I remember it is whatever's last will go on the bottom. Okay? And this is just making sure that B is greater than 0, because if the probability of B was 0, then we would have a fraction with 0 on the bottom, and that fraction would actually be undefined and we couldn't find the probability. Okay? Say we're looking at a fair six-sided die. We've got to find the sample space, which if it's a six-sided die, it could be a 1, a 2, a 3, a 4, a 5, or a 6. That's our sample space right there. And then we got to find the probability and also the subset, or a smaller set, from our greater set S. So event T says that the outcome is 2. Okay, so T is equal to, well, the outcome is 2, so we're just going to write a 2 there. The probability of T, well, I have one number here out of 6 possible. So the probability of rolling the 2 would be 1 out of 6. Okay, event A, the outcome is an even number, so it could be a 2, a 4, or a 6. The probability of A, I have 3 numbers out of 6 total, or a half. Okay, event B, the outcome is less than 4. Okay, so not 4, but less than 4, so 1, 2, or 3. So probability of B would be 3 numbers out of 6, or a half again. Okay, the complement of A, so that would be A prime or A bar. Okay, A is a 2, a 4, a 6. So the complement of A is everything that A is not. So it can't be a 2, a 4, or a 6. So that leaves us with a 1, a 3, and a 5. So the probability of A prime would be 3 numbers out of 6, or a half. Now notice that if you add A plus the complement of A, this was a half plus a half, that equals 1. Okay, A given B. So the first thing that has to happen is we got to look at B first, and then we can find A. So within B, okay, so I'm in this section right here. A says the outcome is an even number. How many even numbers do I have here? Well, just 1. That's just that 2 right there. So the probability of A given B would be 1 number out of 3 choices here. When it comes to conditional probability, that's when your denominator is going to change.